Hello there, welcome back to my channel. So this is part 2 of Inside a Historical English Precision Comparator. So I just want to say thank you very much for all the comments in the comments section. I would like to give a shout out to CED3098 or CED3098 for some excellent and interesting tips and recommendations, which will actually help with making today's project, which is the Phos-bronze band. So in today's video, as I said, we'll be making the Phos-bronze band from a sheet of bronze, but first I need to rub the sheet of bronze down in thickness, measure the width of the band that I took out of the Sigma in last week's video on the SIP, use it as a template, cut it out, micro drill the holes, use an abrasive to clean up the surface, and anneal the material, which is very important to prevent it from being brittle, and then polish it. So that's what we'll be doing in today's video. I will mention this particular project is experimental, because I'm actually absorbing and taking on some of the recommendations based on the comment section, plus my personal experience as well. So I will be doing a few things differently to what I have done before when I made these Phos-bronze bands. I will say, by any means, going forward in the next video, certainly if there's any other recommendations you like to pass over, by all means, I'm open to any other suggestions. So yes, I was initially going to reduce the thickness of the Phos-bronze sheet by using a set of rollers that I have or had, and cold roll it down to thickness, and then after that proceed to cut out the template. Unfortunately, I don't have my cold rollers with me, because I actually lent it to a friend of mine, so I haven't got those with me. So I'm going to have to proceed with rubbing the bronze sheet down with an abrasive and plenty of lubricant. So I'll be starting off with silicon carbide, and then with aluminium oxide abrasive papers with plenty of lubricant, sometimes oil, mostly water, because I don't want to charge the material. But this is not the ideal way of doing this. It would be better to purchase a Phos-bronze sheet of the correct thickness that's required, and then work with it from there. But unfortunately, I've not been able to get hold of that, and so therefore I'll be doing it the long way around. Okay, so now I've just set up the Phos-bronze band on the SIP underneath the scope. So I'm going to measure the width of the band itself. I'll bring you closer. I want to mention this is the other end of the band of the Phos-bronze strip, and what I want to show you, if you can actually see this a bit closer, if I fold this up like that, if I can bring it a bit closer there, I just folded that little end there. You'll notice it stays in its place. Now, if it was a little bit too brittle, then it would snap. So when I make the replacement, we want it to be like this. We want it to be more flexible. So when I make this new replacement, because I've got to thin out the material, plus cut it out, micro drill the holes, polish it. Of course, I'll have to use some abrasive to clean up the edges and smooth the surface. All of this effectively is being cold worked, and so therefore it will harden the band, which means it will potentially make it brittle, and that's not what we want. So what I'll be doing is, once I've done the things I've just said, then I'll be annealing the material. So I'm going to anneal the material to take the springiness out of it, so it becomes a bit softer, but at the same time not too soft. We're looking for this sort of hardness, so it's got to be like this. We want it to be more flexible, and so that when you kink one side, it's not going to snap or break, which it would do if it's too brittle. Of course, when you cold work bronze, like with copper, it will potentially make it more brittle. Yes, so that's what I've got to do, and I've got to anneal the material once I've done with it, and then after that, then I will polish the bronze to make sure it's nice and smooth. Because when I cut around the edges out of the sheet, I'll be using scissors, and there will be roll off, which is the nature of cutting with scissors. And so what I need to do is to abrade the roll off edges and bring it into size and make sure the surface is nice and smooth. There you go, closer up. See where I actually folded up the end of the band. So you've got a kink there now, and it stays exactly, well, it stays in its place without it snapping or breaking. So just looking down through the scope of the SIP universal measuring machine. So you're looking at the Phos-bronze. So now I'm just going to take a measurement, measure the width of the band. And right there. That's the main scale. That's down through the vernier glass scale on the optical eyepiece of the SIP. So it appears to be approximately 0.75 millimeters. So I assume that must be the original width of the band. So I'm just starting off with 600 grit silicon carbide abrasive with water as a lubricant. I'll be moving up in grit size with aluminium oxide, and being very careful not to be too rough, because I don't want to charge the sheet of bronze with silicon carbide. So I'm taking it slowly, and then I'll be moving on to aluminium oxide for the final abrasive. I'm using plenty of sometimes I use oil, but this time around I'm using water. So I'm aiming to get down to 0.05 millimeters. And then I'll set up a template, micro drill the holes, for the band, then cut the band out, and then I will further abrade the surface with aluminium oxide to bring the thickness down to its final size. So somewhere between 0.03 and 0.05, which is what the thickness which is what the original thickness was of the band that I took out of the comparator. I certainly wouldn't recommend doing this next time. I would rather get hold of a Phos-bronze sheet, which is, I would say, a 0.05mm thickness sheet. It'll save me, and it will save me having to reduce the thickness down like I am now. I will mention, I wouldn't buy a sheet exactly to size, because, in my case anyway, because I'll be cutting the piece out of the sheet, and I would be using a pair of scissors, and a pair of scissors can cause roll-off. I have tried using a craft knife, but unfortunately when you use a craft knife, it when you draw it through, it does pull and snag the material through, and you can potentially rip it. So I prefer to use a pair of scissors. So once I mark the template on there, I won't be cutting right on the line. I'll be leaving a little bit of meat on the edges for me to grind away, which we'll come to that later. So I can bring the width in and also the thickness down to its required final size, as per the thickness of the band that I took out of the comparator, as I mentioned earlier. But I'm measuring this as I go along anyway, keeping an eye on the thickness along the full length. And I'm trying not to abrade too much in one spot, trying to keep it as even as possible, measuring it with my micrometer. I cut out a small strip of the sheet because this is experimental, and what I would like to try out is anneal one piece after obviously I actually reduced the thickness earlier, but on this little bit, but I cut this out and I'll further reduce the thickness, and then I would like to anneal it prior to micro drilling and cutting it out, just to see how it will perform. Meanwhile, the rest of it I'm going to micro drill, cut out, and then anneal it later on. And that's what I'm going to do with the rest of this here. So I'm going to work out and see which is really the best, which one works the best way. I've just got a feeling that if I anneal, I'm going to try out the annealed strip for another time, for another video, and I would like to see how it will perform when cutting it out and drilling the small holes after it's annealed. Meanwhile, in this video, I'm going to micro drill and cut out the piece after rubbing it down to thickness as it is, not to anneal this. I will anneal this, but at a later stage, once it's all once it's all been cut out and abraded, and then I'll anneal it before I do a final polish and then fit it into the machine. Whereas the strip that I cut out, as I said, I will anneal that after I've reduced it to thickness, and then try out drilling and cutting that out after annealing. So I just want to see how it will perform, because sometimes I find that if it's annealed before cutting and drilling, it's that malleable that it becomes, the material itself will start to splodge, if that makes any sense, because it's soft. Whereas when I cut one of these out before, I didn't do any annealing, although it would have been the best practice, as I said earlier, in order to take out the stress and the stiffness. But anyway, I'll see how it goes, and I'll compare the two pieces. As I said, it is experimental. Yes, as I said, I'm finishing off with aluminium oxide. So the thickness of the sheet, just measured all on the length, is just over 0.04 millimeters. So that's good enough for me. Of course, I will further rub it down later on after it's been cut out and annealed, just for polishing, and it will bring it down to, say, 0.04, maybe even down to 0.035. Which is the thickness of the, as I said, it's the thickness of the band that came out of the comparator. And if you measure the sheet as it was originally, it was a 0.1 mil thick sheet. As you can see there, it's 0.1. That was the Phos-bronze sheet thickness. It's between 0.04 and 0.05, which is perfect for me anyway on this. So now I'm going to use some double-sided sticky tape, and I'll apply this onto the Phos-bronze sheet, and I will then stick the Phos-bronze band onto the double-sided sticky tape. And then after that, then we'll micro drill the holes and proceed to cut out around the used Phos-bronze band when it's stuck down on the sheet. Okay, just micro drilling the holes. I'm using a 1.5 mil drill bit size. So yeah, just drilling out this. It's a 1.5 mil diameter hole. It's all clamped down anyway. So I've just set up a 1.2 millimeter diameter drill bit for the center hole of the band. It has a smaller hole diameter than the other two. And this is it. So I've just taken the cover off. The holes are drilled. I'll have to open the holes up anyway once I've cut it out using a very fine abrasive down through the microscope. And that's because I've got to make sure you clean the holes out, make sure they're absolutely burr free and there's no fractures. Otherwise, when the screws go through the holes, it could potentially tear. So the holes have got to be really nice and clean. But I'll be doing that with a little bit of abrasive down through the microscope. See that there? So this is the one that's come out of the Sigma, as I said. So what I'll do, I'm going to put the top cover back on again. No, sorry, I'm not going to. No. What I'm going to do now is I'm going to cut around this with a pair of scissors. So I'm just cutting around, but not right up close to the actual band itself. because I will grind around it once I've cut it out. So there you have it. It's cut out. Now what I'm going to do is grind the edges. I'll be grinding this with a little Dremel wheel. And this is to remove all the burrs and the roll-offs which are caused by the scissors. And I'll Dremel grind right up to the original Phos-bronze band template. This is the reason why I don't cut right up to the template itself, so I can grind away all the roll-offs. So I'm just grinding the edges down now. Okay, I've just had this annealed. I ground all the burrs away and all the roll off on the sides, and I've just annealed it until it turned cherry red. And you have to be very quick, because you have to be very quick and very careful, because it's so thin it will heat up and turn cherry red pretty quickly. And if you're not careful, you can potentially melt it. So it's nowhere near as stiff as it was earlier. And hopefully not brittle either. In fact, it doesn't feel brittle at all. Right, so I'll get this polished. And I'll be polishing this with my homemade jeweler's rouge. Okay, so now I'm just going to be polishing this very carefully. This is with jeweler's rouge. And there you are, this is it. It's all finished. Now it's ready to be fitted to the drum here. Onto this drum, which in then turn will be fitted back into the Sigma comparator. So this bowl here is a fresh lot of iron filings, which I saved from machining iron, grind it up into iron filings, and then I add water to it and allow it to rust through, basically into iron oxide. Rust. It hasn't rusted through properly yet, but once it does, then I add olive oil to it and form my own jeweler's rouge for polishing non-ferrous metals. Non-ferrous metals only. You wouldn't use this to polish anything ferrous. Yes, nothing goes to waste. So that's it, that's the Phos-bronze sheet made from scratch. So in next week's video we will fit this into this guy here. I hope you have enjoyed watching this video. If you have, do hit that like button. Don't forget to subscribe to my channel, that'd be most appreciated. And by all means do leave a comment. And yeah, so I look forward to seeing you in next week's video, which will be part 3. And we will be fitting this bronze band into the Sigma comparator. And then from there we'll carry on. As I said, we'll do the anvils as well. Gotta sort out the lapping plates. So all that's to come. Okay, you take care. I'll see you in the next video. Goodbye.